Okay, flexibly renaming. That is a very important skill. To be able to flexibly rename a number is important in addition, subtraction, multiplication, division. No matter what, it's really, really important. I reckon the most common way we rename a number in the real world would be when we talk about cost of something. Say something cost you $1,200. Another way of saying that would be 1,200. It cost you $1,200, mate. That's what we would say in Australia. So we want to be able to do that with all our numbers. We want to be able to rename them, but keep the same value. Okay? So it's really important to get that concept, keeping the same value. All right? When I say, if I gave you a $10 note and I had 10 $1 coins, we would have the same amount. We'd have the same value. Even though they would look different, they would be the same amount. I would be able to buy just as much as you would. So let's have a look at the basic principles of renaming. We need to know that 110 equals to 10 ones. 5, 8, and 10. We need to know that 10 ones is the same as 110. It goes both ways. No matter which way we look at it, 10 ones is the same as 110, or 110 is the same as 10 ones. Now, using that same principle, what if I said you had 2 10s? Well, guess what? You would have 20 ones. 7, 8, 9, 10. Take them away. Now, if I check them, now I wish you had your materials, but for people who don't have these base 10 materials, that's okay. What we can do, put them next to each other. Let's see. There we go. 2 10s is the same as 20 ones. So I'll write it on the side here. 110, not 10, 110 equals 10 ones. There is a little difference, all right? It's the way they look. If I write the number 10, it means I'm talking about 10 ones. If I write 110, I'm talking about 110, all right, like a $10 note. So 110 equals 10 ones. 2 10s equals 20 ones. What if I said to you 6 10s? You would be right. That would be 60 ones. So we can see a pattern here. For every 10, we get 10 more ones. All right, let's have a look. What about our 100? We've got 100 here, 100 block. Now, I wanted to rename that. Well, I can rename that to 10 10s. 3 10s, 6 10s, 9, 10 10s. Now, just to make sure that I'm not lying to you, here's my 100, and I put it on top. It's the same amount. If I take this and put it on top, you can clearly see it takes up the same amount of area. So therefore, it's the same value. They're both equal to 100. However, they look differently. So what if I said 100 equals 10 10s? What would 200s mean? Have a think. Well done. You're right. That would make 20 10s. What if I said 700s? Have a think. If 200s make 20 10s, yes, you're right, 700s make 70 10s. Well done. All right, let's go a bit further. Now, sometimes you can see that 10 and 1s are next to each other in our place value chart. So are hundreds and tens. Sometimes we need to go from hundreds to ones, or tens to thousands. So here's a 1,000 block. It's made up of 10 hundreds. It's made up of 10 hundreds. You can see right here, 200s, 400s, 600s, 8 and 10 hundreds. Now you can see they are the same size. If I put one on top of the other, it takes up the same amount of room. All right, so we've got 10 hundreds make 1,000. So, but how many tens does it make? Because to be flexibly able to rename, I shouldn't just do one place value to the next. I need to think about it in 2 or 3 place value times. So what about how many tens would a 1,000 block have? I need to use my information from before. If 100 equals 10 tens, let's go, 1,000 equals 10 hundreds. And if 100 equals 10 tens, 700s equals 70 tens, that means 10 hundreds equals 100 tens. Now, if you are careful enough, you can link these two. Have a look. So 1,000 equals 10 hundreds, or it equals 100 tens. Now, I don't have enough tens to show you that in real life, so you're going to have to either think really hard about it or go buy some base 10 materials and prove me wrong. But trust me, I'm right. That is how you flexibly rename.